presentation. Okay, hope you can see the slides, that presentation. So we'll be discussing today, rather today and tomorrow also, regarding this data analysis, right? This is a very flat term. More specifically, we'll be looking into data warehousing and data mining aspects, some basic philosophy of data warehousing and data mining, and where this transactional database what we are working at, where it what role it plays. So if we look at if we look at the database applications, right? So it has two broad categories, right? One is what we say this transaction processing, what primarily we are looking at more deeply into this course, right? And another part is more of a looking towards decision support system, right? So it is one is transactional processing, another is the decision support system. Right? When you look at the decision support system, the same data can be meant for different aspects, right? Like same data set, say same data set can be looked into that for a company that is looking at the sales, or same type of data that transactional data can be looked into other aspects, right? So when we look at the data analysis task, we are to basically we want to use this simple SQL and things like that. It may not be always possible to do different analysis, specifically when it looks into statistical analysis or mining type of data mining type of things, which involves say classification, clustering, prediction, and association between different data sets. That may not be always this SQL standard SQL what we are looking at, or whatever the transactional processing what we look at may not be sufficient for handling these things, right? So we may need to reorganize the data or look into the data into other aspects of it. So specifically, any decision support system, basically at the ground level requires statistical analysis, and different packages like SAS or S++ can interface with the databases, right? So different statistical packages if you have used, so you can have a backend database which can talk to it, right? Over which the things will be there. Some basic statistical operation or basic we can do with our standard SQL, but it cannot be extended, or it cannot be extended to do large scale operations, right? Specifically, if I want to look into that things like which involve some sort of decision making type of things, we'll come to that, right? Like if I want to look at that say what is the trend of say a particular product or things like that. So the data mining, on the other hand, seeks to discover knowledge automatically in the form of a statistical rules or patterns of a large scale. So when we look at any large databases, so what we are talking about, it's not our lab scale database, right? So the databases are pretty large. Think about say a banking system, right? Think about State Bank of India or any other bank, nationalized bank altogether. So the volume of data or volume of transactional data is pretty high to take a particular any call. Or even if we look at some of the things like say some chain like Walmart, or in our country Big Bazaar or Spencer's or things like that, what we see that if you see that at the management level, what is their one of the motivation towards analyzing these data, large databases, are maybe that what is the, like, how is the say sales are going on overall or on a particular category of products, right? And whether there is a increasing trend on some particular product, like maybe a particular type of dress or particular type of car or particular type of, say, other electronics gadget like mobile, etc. So what is the overall trend in those things? So that needs to be looked into. That there is one of their basic motivation, and we'll see when we discuss little more on the data mining. So if you look at any market, like any departmental store or things like that, what the basic objective of the management, what they say, it is a something like market basket policy, right? So in the sense that that your the basket you are carrying inside a departmental store to fill up, it should be filled up with your minimum movement and things like that. So how quickly I can fill up so that you can basically check out and things like that. So what are the transactional data what you are capturing is basically one is that at the teller counter, right? Whatever at the outgoing counter, whatever you pay, and what are the different type of products and things. It also speaks about some of the trend, like many people are buying some type of product. So we find that there is a trend in that particular product, say a particular type of, say, garments or things, or particular type of food products. So accordingly, as a on the management side, my tendency will be to have more those products available in the store so that it is there. And there are a lot of other effects, right? So it is not only the data which is there. There are effects like it varies with seasons, right? So like woolen garment trends will be some time, and at the when the now the summer is coming, so people will less buy this woolen garment, so they will start giving offer. Otherwise, they have to hold it for another 6 to 10 months, so that again the trend comes of buying those garments, right? So that is one part. Another is that there is a seasonal effect. There can be something which is event driven, like there are festivals, etc., which drive some of the things. There can be something which is something which is may not be predictive. You cannot predict that a priori, right? There are say some crises due to, say, or something like if there are more demand for suddenly, like all of us came to this online system, sudden surge in buying products like laptops, phones, etc., which can support this online system, even requirement of bandwidth, and there are different other products, right, which was not as such predicted for a means continuous fashion, but there is something which happens, right? So what we see, there are multiple dimensions which comes into play when we want to do some meaningful analysis, right? Which is not per se is there when we do something which are with a more very confined on a domain, like we are doing something with the student database, something with the library database, or even banking database. But if you are then if I'm concentrating on that those particular domain itself, then I may not always considering that external effect. So what we see, that even predicting that what is the sales of a particular overall or a particular product, or for my departmental store, or even my, if I have only a shop itself, that depends on a lot of other factors, right? Like starting from as I told, that it can be seasonal, it can be some events which are not predictable, even it is maybe effect of that what sort of culture is there, like if I am having food product, what sort of food people like, or what sort of level of purchasing level of the things, right, of the people around the things, right. So it all depends, lot of other factors or lot of dimensions where things are there. Rather, what we see that taking all these dimensions, what I want to do, I want to collect some of the basic parameters, or more I can say some facts which help me in analyzing the things or taking appropriate decision making, right. Rather, this from this we come to a concept what we call is data warehouse, right. A warehouse, as we know from our other notion, like it's a collection of different sort of products of different products or different type of in different type of products of different domains, and to keep it in a for a long type, and can able to serve different type of demands, right. In our case, the things are there, it is more of a querying on this warehouse or taking intelligent decision on the things. So a data warehouse archives information gathered from multiple sources and store it under a unified schema or at a single site, right. So so as we are discussing, so it collects data from multiple sources, and it stores them in a single repository logically, and under a single unified schema. That is important, as we have seen in the database also. The schema plays an important role, right. Unless your schema supports, you cannot have that query. So here also we need to have a schema which able to support this type of multi-dimensional data sort of things, right. So important for large businesses or large scale operations that generate data from multiple divisions, possibly in multiple sites across different geographical locations, having different say socioeconomic what we say culture and socioeconomic status, right. So that can be there. Like if you consider even large stores like as we have seen Walmart and etc., they are across different countries, or even things like if you say food chains like McDonald's or KFCs, which are across the globe, right. So they have a huge volume of data, and everywhere the trend may not be the same. So that requires a different way of analyzing the data other than writing simple SQL, not simple, even complex SQL queries, right. So even some of the data can also be purchased externally, right. I want to look at that how the trend will be there, and I take from IMD, like Indian Meteorological Department or other things, and purchase the data. Even I want to purchase some of the data, that what is the trend in, like maybe purchase or acquired data like so-called pandemic situation. So how quickly, or how, what is the trend of opening up of this whole economy and etc. Accordingly, I work want to do some call. So when there is a large thing, large organizations, businesses specifically, even at federal government sites where this huge volume of data needs to be churned for appropriate decision making, that it becomes an important factor. Okay. Hmm. What we see, if we look at the data warehouse, it's a data sources often store only current data, like normal data. What we do is basically whatever the data at present, right? Whenever you are querying something, acquiring, so it is the current data, or the data is in which are there, not the historical data per se, right? So not that what we say different timestamp, right? And there are also issues in this, that all those historical, when we look at the historical data, the data set may have different granularity, right? Temporal granularities, right? Some of the data set may be changing daily basis, some may be hourly basis, some may be weekly basis, and some may be more right like quarterly and things like that, right. So they have different, what we say, temporal scale of doing that. So handling those are in a different ball game altogether. Nevertheless, again, what we look into, that as we are discussing, that analyzing the data, that also we can look into different perspective. Like I want to look at that daily trend or weekly trend or even monthly or quarterly or maybe yearly or maybe 5-year scale and things like that, even if we look at that trend wise, right? So once we have a larger time span or when it is increasing, then the other dimension may be affected. Like the type of supply you are getting, that time you cannot say that the same supply or same type of things will be existing. Like think about say our computing devices or mobile phones, right? You can't expect that the same trend on the things will be going for 5 years and things like that, right? So those are things which has different type of semantics or other type of into play. We are not going to lot of nitty-gritty. We'll try to see that how those there. So corporate decision making requires a unified view of all organizational data, including historical data. Right? When we want to have, so we need to have a or we want to keep them on a what we say common schema. Unless we can have a database schema where it contains different type of relations, as we have seen. So it is doing any appropriate querying on the things, right, is a difficult challenge. So a data warehouse is a repository or archive of information gathered from multiple sources, including external sources, right, stored under a unified schema at a single site. These are logically in the what we are talking in the logically in a single site. It can be, suppose you are storing over a cloud infrastructure, it may be distributed, but what you look at is a logically a single site, right? Nevertheless, it is for a, if I am business, it is single site for me, right? So greatly simplifies queries, permit study of historical trends, right? So it allows you to have run queries and things. And SIP and support query loads from transaction processing systems, right? So not from that transaction processing, but in the things. So what we try to look at, if you see this, it is more aligned to the business logic, right? So what business you are, what is your thinking process, what is the management thinking about it, or data analytics at your end looking at it, and based on that you want to have those things into the things. It may be a rule, it may be some prediction model, it may be some association. If this happens, this also happens. We'll see some of the things, like if I say if I buy bread, I buy butter also, right? This is a trend. I buy butter, or so bread, butter is a is associated strongly. If you buy, say, printer, you are likely to buy cartridge within after some time, right? Or things like if, that's why we see that once you buy something in some of that our e-commerce site, like it may be Flipkart, Amazon, or other different eBay and things like that. So you buy something, it immediately comes up with different suggestions, right? You buy a mobile phone, it says that whether you require a cover, whether you require a, say, that glass in the front and things like that, whether you require insurance also. So all these things are why they are associated. Now, given a data set, finding the association between the data is also a challenge, right? How do I know? Some are maybe in my back of the mind, right? That's why even if you have big large departmental store type of things, so you see that you have a garment section, you have a food section, you have a grocery, you have, say, electronic section, things like that. It is expected that once you are in the garment section, you are looking for different type of garments, so you should not be running about around the different floors and different corners of the things, right? But whether how do I judge that if you buy something, you will buy something else, right? So one way of looking at it is one way from your own data is the data which is being collected at the teller counter, right, or the checkout counters, right? So you know that what bunch of things people are buying, right? So you can have a connectivity. Oh, if these are the items bought, these are items also likely to be bought. Right? So that what we see, that there is a association between that. That we will see that association rule mining, how it works and things like that. And then want to see that how much support and confidence I am having on those things, right? So how good is that this association, right? If it is a good amount of support and I am confident how to measure, we'll see. Then I may invest on those products, may hold more on those products, and not only that, other things I may want to keep them together, right? Bread and butter, I want to keep them together, right? If I find that people are buying shoes and socks together, which is a trend is there. If I find that a lot of trend is there, that if you are buying shoes along with that something t-shirts, then we bring them together. So those things to be together. So this rearrangement of these cells is also things which may help in that my that customers marketing basket will be filled in a less movement, and he or she maybe buying a lot other than things, right? What if you those if you are visiting this departmental store, you have a usually people have a tendency of buying more what they planned for, right? So that actually those things actually they are nearby things. Anyway, so data warehousing, what we want to do is, given the transactional data, we cannot give away with the transactional data, the data which is collected at the source, right? So I cannot, so all those things whatever we are doing. So, but given the transactional data, so the overall data set may be so large, it may be difficult to look into those data sets, right? In a or analyze that data set. So I require a schema which will not only have my data set, also can external data set, and allows me to do something more in the direction of decision support. Okay. So there are a few terms already you may be knowing. So one is the OLTP, online transactional processing, major task of traditional or relational database, what we are working, that is absolutely necessary. So day-to-day operation, purchasing, inventory, banking, manufacturing, payroll, these are the things. If we look at other things like recording of this is say weather conditions by the sensors, etc., or even our academic data, all those things are all are going to a transactional processing, right? So that is the OLTP, online transactional processing. On the other side, what we look at is the OLAP, online analytical processing, right? Major task of any data warehousing based system. So analyzing the data, taking appropriate decision making, these are all comes under this online analytical processing. So that given the data, how I can do that. For that, I need to have a schema which will be all encompassing. There are definitely some distinctions, though they go hand in hand, right? So one is the data content wise, so current, detail versus historical, consolidation of the data, and so forth. So these are some of the things which are what we see in when we look at that this difference between them. Database design, where we have more of a ER based like entry relationship than what we have normalized design. So normalization, as you have read or reading in your that theory course, plus different application based on that, where here what we have different type of other schemas like star schema, which are more subject oriented. We'll see when we go on discussing. Again, with respect to view, that current view, local versus evolutionary view, integrated view of the things, and access pattern. So here it is, access is querying, updating, etc., where the transactional data set. But where if when you look at the data warehouse, they are definitely their updation is required. But from the consumer point of view, that they are more read-only but more complex queries involving different data repositories or different what we say data schemas of different dimensions comes into play, right? So what we look at, that OLTP is more allowing you to collect the grassroots data and make it available in a data warehouse form. That should be definitely a way to put this data to update the data warehouse. That has to be there. But along with that, this what OLAP is trying to analyze this data for more towards decision making and data analytics part of the things, right? So this is more of a feature wise, like user here is more of a OLTPs that it may be clerk, it may be different other people like common users, what we say. So who are receiving, querying and updating data based on their authority on the whatever they want to do, right? And and what we look at is other is the OLAP is more of a knowledge driven, right? You want to do something analysis based on your thing, right? So if your business is something which is a departmental store, you want to look at the different product trend, etc. If you are involved in say meteorological department, you may be trying to predict that future weather condition, or even looking at more of uh, things like that, something abnormal weather condition, etc. And if it is a something as a defense domain, then there is a different aspects, and it goes on different. So functionality wise, it is a more of a day-to-day operations, and whereas OLAP is more of a decent support system. It can be daily, weekly, monthly, and things like that. If we look at the database design aspect, it is more specifically on the application oriented, right? That is more of the applications what you are looking at, where this is more of a subject oriented, like which domain or which subject you are looking at. So again, data wise, in case of OLTP, it is current, up to date, detailed, flat, relational, and at times isolated. So these are the data sets what we look at, right? Whereas in case of OLAP, these are definitely these data sets are there. These are more of a historical data, where as a in the temporal scale, we can have summarization of the data, multi-dimensional, needs to be integrated and consolidated, right? This usage wise OLTP is more of a repetitive, right? So you are doing some of the things which are functions are there, it is that repetitive work. Whereas in case of a OLAP, it is more of a ad hoc. When you require a decent things, or whether it may be it may be on a routine basis, or it may be on some exigency situation. So it can be those type of can come up. Access is wise OLTP is read write, as you have seen. There will be also seen that index hashing on primary keys and things like that. And where OLAP is not primarily meant for the updating the data. It is more of scanning the data for different type of decision making things, right? As we are telling, it may be rule based things, it can be a predictive, it can be association, it can be clustering, how the data clusters and things like that, right? Like as we told that we work on some of the aspects of like traffic data, right, or mobility data. We do that. What sort of cluster we are forming on that things. What is the pattern that if there is a cluster here, there is a cluster, whether there is a linkage between this cluster. So anyway, what we say that it is more of a scanning the data, underlining data, and do some reasoning. So unit of the work, this is unit of work is more of a short, simple transaction. Not always very simple, but definitely simple with respect to the complex queries which are involved in the OLAP. And records are maybe tens to hundreds. It is not tens of things. OLAP tens to hundreds, but in case of OLTP, whereas in case of OLAP, it is something much more. It is million and billions, and even some of the cases, if you consider the temporal scale, it may go up to trillions of data, right? So anyway, it's a huge volume of data which need to be churned, and doing it any sensible time is a serious challenge of doing that, right? Users are usually OLTP, good amount of users, thousands of users, whereas in case of a OLAP, these are mostly decisions making people. Uh, so the number of user may not be there pretty that high. So with respect to this OLTP users, database sizes in case of OLAP is pretty high, terabytes, and people are also talking about now petabytes of data, especially the data which involves this say weather monitoring and large scale climatic analysis and things like that. So it's a huge volume of data. So data size is enormous, and metric transaction throughput, etc. And here also we'll see that some of the query throughput, and there are different other metrics which come into play. Even if we have a prediction and other type of things, which are this is one of the goal of data warehousing, data mining, and OLAP type of things, which is more of a uh, more of a that accuracy and other things come into play. So, mm, uh, so that makes uh, a basic difference. It may not be. We'll see that more when we go through the thing. Uh, so these are the things. So what we see. We see that there are definite need of warehousing this type of large data sets. Uh, 1 minute, just hold for a minute. There is some problem. 1 minute. Sorry, there is a sorry for the interruption. I have some problem. Okay, now it's fine. So what we see that why we need this warehouse, that is well understood so far, that when we require some sort of a data decent support system, or when we want to mine the data for some prediction model, etc. So this our this standard OLTP type of operation may not be sufficient. We are not giving away with that. We can't give away with that. That is the data where the sources, what the data source is there, right? So what we see that we require. Sorry again. So what we require something high performance for both the systems. The DBM is tuned for OLTP, right? Access method, indexing, concurrence control, etc. Warehouse is tuned for OLAP, complex OLAP queries, multidimensional views, and consolidations. Right? So different functions and different type of data, missing data, decision support queries requires historical data which operational DB do not typically maintain, right? So your or operational databases do not mention. So there can be some of the missing data, and handling of the missing data also may differ, because see, when you are churning a huge volume of data for some say prediction, etc., if you miss some of the data, say it may not be having very great effect on your prediction model, right? We can definitely we have a measure that how much data we can still forego with, but in case of a OLTP, that may create a serious problem, right? Data consolidation. So decision support system requires consolidation, like aggregation, summarization of the data from heterogeneous sources. Where in case of a OLTP, that may not be the always requirement. Definitely there are aggregation operations and things like that, but that operation and the scale where that is our decision support system works is a different scale, right? Data quality, different sources typically use inconsistent data representation, codes, formats, switches. So there is a not only quality, there is a serious challenge of data interoperability, right? How the data will interoperate. Like if you are taking, suppose for the prediction, I am taking for that prediction of my departmental store, I am taking data from my own that checkout counters, like how the trend is there. Along with I want to take that meteorological data, want to take some of the things like overall economic data, like what is the how is the thing, and maybe in this situation even the pandemic data, right? Now these are the different sources of the data. Now how they will interoperate, what are the data quality, I may try to ensure the quality at my end, how to ensure other end, and whether that type of things are there. And once I want to take this different dimension and take a call, what should be my way of approach. And there are more and more systems which perform OLAP analysis these days directly on the relational database. We'll see some of the things in your lab also, like on the Oracle database at the back end, how these different type of operations can be performed, right? We see it's a process from the data to meaningful information, what we are trying to transform, right? Process of transforming data into information and making it available to user in a timely and enough manner that makes a difference. So we'll continue in the thing, but let me just give you a overall big picture. We'll come to these things later on. So if you see this big picture of the overall your data warehouse based system. So one end we have these operational databases, right? It may be like as the checkout counters of the things. In our cases, this all what the data you are entering in the academic data, etc. Like so, these are the operational databases, right? So the ERP, etc. Like different forms, etc. We are entering data, extracting, firing query, getting some of that information, right? On the other hand, is that how do I analyze, query, report, mine the data, right? So this is our objective. So when we have a data warehouse based system, some of the queries I can fire here and get, that's absolutely fine with the OLTP we are doing that. So in between, what we have a data warehouse, right, which is more of a consolidated schema of multiple dimensions of the data or multiple sources of the data, right? So what we see that we extract this data from different sources, extracts, transform, load, refresh this data warehouse on a particular periodic manner, right? Some of the things like once we want to have query, etc., anything on the things, I need a metadata or the information about the data, right? And also which have a, I need a monitor and integrator which looks into the metadata. Suppose I have a query which involves 2-3 database schema, then whether my metadata is supporting that, and then how I can have a particular so-called quote-unquote application schema to run on the things has to be judged into, right? There are other concept of data mart will come later on. So this OLAP servers are somewhere here. So it looks into the data thing, data warehouse, and wants to do some basic OLAP operations on the things, right? Like which moves on different data set and things like that, right? So that is the way what we look at the OLAP server here. And finally, we have these different analytic tools queries on those things, report, and some things what we say data mining, right? So mine the data for something more than what OLAP supports, right? Or what more than what that OLTP or other type of queries, right? So let us stop here today. We'll be continuing this discussion again tomorrow. Rather, if you have any, let me say that. So if you have any query on the things what we discussed, you may ask now, or we'll be discussing tomorrow. Stop the recording also.